Hello and welcome to this episode on Revieiwing Key Engineering Plastics. My name is Herwig Juster and today we have a closer look at polycarbonate. Similar to the last review on aliphatic polyamides PS6 and PS66, we review the chemistry including the simplified petrochemical flowchart, discard the properties and applications of polycarbonates, and look at the global demand and producers. I will provide you with some price indications as well. Before we start with the chemistry, I would like to spend some words on the history of polycarbonates. In 1953, Mr. Fox from General Electric Plastics prepared the first sample of polycarbonate in his lab. At literally the same time, Mr. Schnell from Bayer AG from Germany discovered polycarbonate, and the patent fight between those two inventors started, which could be luckily settled and allowed a high volume production of polycarbonate. So what are the properties and what is the chemistry of polycarbonate? Polycarbonate is an amorphous polymer with a glass transition temperature of 147 degrees C and a melting temperature of 160 degrees C. It is transparent and has a density of 1.2 grams per cubic centimeters. There are two ways to obtain polycarbonate: the phase transfer process and the so-called melt process route. The phase transfer process is an interfacial polycondensation between phosgene and bisphenol A in an organic solvent. Phosgene is not environmentally friendly and therefore a more environmental compatible process was introduced, which is known as the melt process. The phase transfer route is a batch process and suitable for specialty polycarbonate grades. The melt process route consists out of melt transesterification of BPA and diphenyl carbonate, in short DPC. DPC is obtained from dimethyl carbonate and phenol, or directly over carbonylation of phenol. In the next step, DPC reacts with BPA to form polycarbonate precursors. With the precursors, polycondensation can take place to obtain high molecular weight polycarbonate. Let's have a look at the simplified chemical flow chart. Where does polycarbonate has its roots? As already mentioned before, bisphenol A is one of the major ingredients. The simplified chemical flow chart helps us to understand where the BPA has its roots. BPA production needs phenol, which is obtained over the so-called cumene process, which uses benzene and propylene. In detail, benzene is alkylated with propylene, which results in cumene. In the next step, cumene is oxidized to obtain phenol and acetone. Acid catalyzed condensation of phenol and acetone leads to bisphenol A, which then reacts with diphenyl carbonate DPC to polycarbonate. Polycarbonate properties. Impact resistance, ductility, clarity, and dimensional stability are major advantage properties, which makes polycarbonate an excellent engineering plastics. Furthermore, polycarbonate has inherent flame resistance, good electrical properties, and can be used for elevated temperatures up to 120 to 140 degrees C. Regarding chemical resistance, polycarbonate has poor solvent resistance, notch sensitivity, and limited hydrolytic stability. This needs to be taken into account during material selection. What is the global demand in polycarbonate? In 2016, global polycarbonate demand was 4 million tons and 27% of the consumption was used in the electrical and electronics market, followed by the construction and automotive market. Geographically, you can state that Asia is with 59% of global consumption the largest market for polycarbonate. What is the price to performance ratio? Polycarbonates are forming the base of amorphous engineering thermoplastics and have a price range of 2.5 euros per kg for base grades. High heat modified grades are in the range of 3 euros to 3,60 euros per kg. What are the end uses of polycarbonate? Polycarbonate covers a wide range of application and essentially it can be structured in 6 areas. Electronic components, where polycarbonate is a good electrical insulator combined with heat resistance and flame retardant properties. Major applications can be found in the construction materials too. Typical representative are glazing applications, flat or curved sound walls, doom lights. Data storage application like compact discs, although not that heavily used anymore, are made out of polycarbonate too. A fourth major field is transportation, split into automotive, aircraft and railway, covering decorative bezels, optical reflectors and headlamp lenses. Medical applications are using polycarbonate too, since it complies with ISO 10993-1 and USP Class 6 standards. Last but not least are smartphones, where cases and battery covers are frequently made out of polycarbonate. So typical polycarbonate applications. On this slide you can find some main polycarbonate applications like helmets and helmet visors, smartphone housings, sunglass lenses and kitchen appliances. Okay, this was a review on polycarbonate, a versatile amorphous engineering thermoplastic used in many applications. Thanks for watching and I'm looking forward to next time. Greetings!